Hello and welcome to Java. Today I'll be talking about variables and constants. So let's begin by creating a scanner. This is just to import data from the user. So we're going to import java.util.scanner. Close that off. And let's create a scanner here called input. And make new scanner system.out. .in. And there you go, that's our scanner done. Okay, next, let's talk about variables. So we have integers, doubles, char, which is basically a character, a boolean, and strings, and I think that's the ones we're going to be talking about today. So int is going to be integer, which is any positive number without decimals, and let's make that length, width, height. And close that off. So basically, you can separate the variables by commas. And we have length, width, and height, which we're going to use for volume calculation later on. Okay, next, let's do a double. And we're going to combine that with a constant. Constants are going to be called final, followed by the data type, which is going to be a double, and by the name pi. I'll just call pi for fun. Now we're going to make that 3.1415924654. Right, that would be pi about. And I think that's it for the double. Next, we have a boolean. We have a boolean, which is true or false. So let's call that decider. And let's set that to true. And close that off. Finally, we have char, which is a character. And we can do char letter A, let's say, becomes, and we're going to not double, we're going to do a single quotation and call that A, and close that off, as well as we have string. Let's say string sent, for short for sentence, and we can just close that off, or we can initialize, say hello world, period, and close that off. So basically there we have our 5 simple data types. Next, let's create an application using integers. So we're going to say system.out.print, and I'm going to say enter the length of the rectangle. Right? And period. And then we're going to do the semicolon, or just the colon. Close that off. And we can do length becomes input dot next integer. Close that off. And again, system dot out dot print. And let's call that enter the height of the rectangle. Right, and then the colon space. And let's call the height is equal to the input dot next integer. Alright, close that off again, and the same thing, system dot out. And let's say enter the width of the rectangle. There you go. And close that off. Let's change this one quickly. And the same thing, right? Width becomes input dot next integer. Close that off. And now we have our variables that we need for volume. And we can just say system again dot out dot print and say the volume is, and then we can go outside the quotation plus, and we can do our volume calculation right here. So let's add a new variable and call it volume. So now let's do volume equals length times height times width. And close that off. So now if we're to put volume right here, you can see that the volume is going to be length times width times height. So now if we were to run this program and input a value of 3, 2, and 4, we get 24. 2 times 3 is 6, times 4 is 24, and the volume is 24. The print line makes it look cleaner. So that's a very simple way of doing it. And we have the final double. We can do a same thing for a sphere. That would be our radius. No, that would be our pi. So we can just do 2 pi r squared, and that gives us a certain amount. And then we can just use that in the same way we just did here. Ask for the value, get the value, and then calculate the value, and then input it out again using the system.out.print. Next, I have a little thing here showing the operators of Java, which we can use. These are not all the operators, but these are the most of them. The ones that are you're most likely to be using at this point. So these are it. We have system. Let's just run the code to see what it looks like. Right. So let's take a look. So we have 65 plus 4. That would be our addition thing, and that becomes 69. 11 divided by 2 becomes 5 if you're using integers. And we have a drop remainder of 1, so it gets rid of the remainder and just rounds it down. And then 5 minus 2, that would be our subtraction, which becomes 3. And then 4 times 4, that's our multiplication. It becomes 16. 21 mod 4, modular division, which gives us 1, because the modular division gives you the remainder of whatever you have left. So in this case, 21 divided by 4 is going to be 5, with a remainder of 1. And modular division gives us the remainder, and the remainder, in this case, is going to be 1. So our answer is 1. There's a few applications for this type of thing. I'll show you them right now. Object height. So we have the object height in meters, and we're going to find out what the object height is going to be in 4.5 seconds or less. Depends what the user drops it. So let's take a look. So we're going to have 100 meters is going to be our height. And the equation is h is equal to 100 minus half at squared, where it's going to be basically 4.9 times the time squared, where t is the seconds. So now we're just going to create an object height application that promotes the user to input a time less than 4.5, then displays the height of the object at that time. The application, it will look like enter a time less than 4.5 seconds, so they enter 2. And the height of the object is going to be 80.4 meters above. So let's just try to do this. So we do system. Start here, system.out.print. And let's say enter a time less than 4.5 seconds. So now they enter a time less than 4.5 seconds. Let's add a new variable. Let's add it down here so it stays with our code. Int. Actually, let's do double. Double. And then call it t. That's because it's our time. Close that off. So now we can do t becomes input dot next. And this is where we can do the double. Close that off. And the equation is as follows. Well, we also need another variable called height, so let's call that height. So, because we already have that, so let's call it height g, height gravity. Just for this, height g is going to equal to 100 minus 4.9. And then we can do this, t times t. Close that off. But we also have to put this sign, plus. So this t times t is the same thing as t squared. And now we can just put in this, system.out.print, and say the height of the object is, and then do our semicolon, plus HG. So now if we were to run it, and then let's say enter a time less than 4.5, right? So we enter 2, we get 80.4. But now let's see how we can just see how if they're entering a thing less than 4.5 seconds. So let's take this, and let's just say if let's move that up there. And if t is equal to or greater or equal to 4.5, let's use a while loop. While so it's going to keep repeating. And now we're going to say system.out.print. I'm going to enter a time that you just type in less than 4.5 seconds. Give them another try. And say t becomes input dot next double close that off, and now it'll keep doing this. So it's, again, this code just became a little more complicated by adding the while loop. So now it's just going to keep asking them until it's less than 4.5. But also, we want it to be greater than 0. So we can do a and t has to be greater or greater or equal to 0. So if those things are true, so they put in -6. You can't really do -6 with time. So it's going to be has to be greater or equal to 0. Now let's try it out. Right, so enter a time less than 4.5 seconds, let's say 5 seconds. And it says enter a time less than 4.5 seconds, so you can do 4.5. But it still has to be less than, so you can do 4.4. And that gives us a height of 5. So now let's figure out how to round these decimals off. So now let's just do a quick import. This is to round off the decimal to a nearest one place. So we're going to do import. It's going to be java.util.math. I'm going to close that off. Oh, no, not util. It's going to be lang. And now we can do, right here, hd dot, or not dot, it's going to be math dot round, and do that, and just do hg. And there you go. So now it will give us 5, basically. So let's try it out. So let's say we do 4.4 again, and it's just going to say 5. Try that again. Let's see, let's enter 2. Gives 80. And there you go. I think a change application will actually be quite good. So this one's going to be called system.out.print. And let's say enter the change in cents. And we can just close it out and do the same thing. Let's just add our integers here. We can say int. And let's call that change. Close it off. And now we can do the same thing. Change becomes input dot next integer. There you go. And now we can do change becomes, for that we have to do system.out.print. Now let's say let's say the number of quarters is, space, and then go here and say change mod. Remember that gives us the, oh not change mod, change divided by, and there's going to be 4, so we need to divide that by 25. Close that off. There you go. So the number of quarters is going to be changed by 25. So if I input 100, it's going to say 4. But if I input 112, it's going to say 4, and it's have a remainder of the remainder of 12. Let's see this again. And let's say 123. So it says 4, but it doesn't give us the decimals. So now we can do this. Change becomes change minus, and then we can do this. Change divided by 25, and then times this whole thing by 25. And now you'll see the reason for that. Let's just take a look at this. Alright, I forgot to close it out later. So the change, which is equal to, let's say, 112, this is here, 112, minus, this is going to happen first, so we're going to get 4, times the 25, which is going to give us 100, minus the 112, so now this is going to be showing 12. Change now becomes 12. So we do system.out.print and say the number of dimes is, and just follow the same thing. Change divided by 10. And if we had the same thing, it will give us 1 with a remainder of 2, and that's going to equal to change, and the same thing, right? But this time we're going to do minus 10 times change divided by 10. So now same thing, right? We have 100, but now this took away, so we have 12. 12 minus 10 divided by 2, or change 10 divided by 12 divided by 10, and that equals 1 with a remainder of 2. So we times that 1 by 10, we get 10, subtract 12, gives us 2. So now let's say system.out.print, and let's say the number of dimes, or not dimes, yeah, the number of dimes is, quotation marks, the same thing, plus change divided by 5. This one should be nickels, that was my mistake. There you go. And the same code. So we're using our variables. We come up with a change equation. It's very simple, but still you still have to think about it how you would do it, right? So times the change divided by 5. Close it up, and now same thing, right? We have 2, and 2 divided by 5 in this case is going to be 0, and 0 times 5 is 0, so we still have 2. So let's keep going. System.out.print, and let's say the number of pennies is change divided by 1. So now this should be our final value, and that's it. So let's take a look. 1, 1, 1, 2. I'll say that. Enter the change in cents. So we have that was a mistake. Let's do 112. So what we should see is 4, then 1, then 0. Oh, I forgot to do the line thing, just to make it look all nice. Let's do some changes. There you go. Let's try this again. Let's say 112 again. So we have 112, and it's going to be the quarters is 4, the nickels is 1, the dimes is 0, and the pennies is 2. I hope this little variables and constants tutorial helped you out. So just to recap what we talked about the integer, the double, the constant, which the constant is just the same thing as you would use a double. But basically all it is just you can't change it. So is there a purpose for it? Maybe. But in this, I'm used to using a double and just not worrying about it. But I think it's a good habit to get into, just making it a final and just using it as a constant, just to make sure you know what your constants are. Booleans are deciders, which you could use as a true or false. So you could do an if statement or a while loop that only activates if it's true. At the end of the loop, if the requirements are met, you can do a false. And that will end the loop, and then they can proceed with the code. Right, so we talked about the length and the width, how we can take the input from the user and then make the variable the input. So we get our length, the height, and the width. And then we can do a calculation for that. So we can do a volume calculation with the length times width times height. And that gives us the volume, which of course we tried out with 2, 3, and 4, which gives us 24. And we saw our operators, which are addition, subtraction, division, multiplication, and modular division. Modular division, it gives us the remainder, and the division just gives us the number which is divisible by and drops the remainders. And then we just did some examples with the gravity. We have our t, which is time, and we did while statement. While statement that finds the variable and it measures it up to a certain value. So if the t is greater than 4.5, we ask them to enter it again. If it's less than 0, we ask them to enter again. When both statements are true, we get the input and we use that input to calculate the height of the object in the air. Right? So hd equals 100 minus 4.9 times time again, and that gives us a thing. And then we just talk about rounding, right? Math round, and that gives us to a nearest ones place. And then the change thing, this is just showing how you would use kind of the right techniques to calculate certain values. So we get the input, and then we can trickle all the way down to pennies by just taking what we know, subtracting it from the number, and then again taking what we know to subtract from just to calculate the amount of money based on the amount of cents they would have. And you could do this with dollars. You could do it pretty much with anything. They input, let's say, $124.35, and you can calculate the exact change. That would be a very complicated thing to do, but you can still do it. It takes a little time. And on that note, thanks for watching.